Good morning, everyone. Today I am going to discuss the last session continuation of that example. What we have discussed that 5 number summary, minimum value, maximum value, quartile 1, 2, 3, interquartile range, and box plot. So let us solve one example, including all these 5 number summary using the box plot. Here is the example. Suppose we have a data set of runs scored by a batsman in his 12 matches. Now we are going to arrange this data set in descending order first, and then we are going to divide the data set into 4 equal parts. And now the question is how we are going to find out 3 percentile, that is 25th, 58th percentile, and the 75th percentile of the box plot. So what is this percentile? Percentile is nothing but the number below which a given percentage falls, or you can also apply the below formula to find out the percentile. Let us see the formula, how we are going to find out this percentile. So what is how a percentile is given is position of the number for given percentile is given as P of n is equal to percentage of n plus 1 divided by 100, where this n is number of items in the data set. If you take earlier example, it is 12. Why? Because 12 matches. So 12 is the n value. And if the above results comes in float in decimals, that is, then we are going to take the mean of two numbers. That is P of n and the beside number, that is preceding number, that is P of n plus 1. If the results comes in integer, then just directly we are going to take the value of Pn. So let us represent this with our example. In our example, we know that n equal to 2. Then position number for 25th percentile, if you give this formula, that is the percentile is 25th. So we are going to, in place of percentile, we are going to write it as 25. And we know that n equal to 12 plus 1 divided by 100. So we are going to get, we got a value of 3.25. As we said earlier, if the result is a decimal number, then we are going to take mean of third and its preceding number, that is fourth number. Similarly, position number for 50th percentile, that is 50, 12 plus 1 divided by 100, which equals to 6.5. Again, we got a decimal number. So we are going to take the mean value of 6 and its preceding number, that is the 7th one. Next, 75th percentile, that is 75 into 12 plus 1 divided by 100, that is 9.75. Again, the result is a decimal number. We will take the mean value of 9 and its preceding 10th number. This is how we are going to find out the percentile for a given data set. So let us visualize it. So Q1, that is also called as 25th percentile, that is number below which 25% is falling. Q2 or 50th percentile is number below which 50% is falling. Last one, Q3 or 75th percentile is number below which 75% is falling. Now, let us represent the same example with this. That is run scored in 12 matches is these are the runs. Okay. And as we said, the 25th percentile is a combination of third place and the fourth place. Why? Because we got a decimal value. That is, the Q1 is equal to, the 25th percentile is also called as Q1 equal to 17 plus 17 divided by 2, that is 70. Okay, that is the 25% of the data. Then, next 50%. We calculated earlier that we got decimal number. So, we are going to take the position of the 6th and 7th. 6th and 7th, that is Q2. 6th and 7th. So, 19 plus 20 divided by 2, that is 19.5. That represents the 50% of the data. Below this is called as a 50% of the data. Then, Q3, or we can also call it as 75 percentile, that we got it as value as 9 and 10. So it is Q3, that is 23 plus 25 divided by 2 equal to 20. So the number falling below this is called as the 75th percentile. That is 75% of the data. So this is the 4 quantiles or quartiles of the given data set. Then we know that Q1 equal to 17, Q2 equal to 19 point, and Q3 equal to 20. First, let us find out the interquartile range, that is IQR. We know that it is Q3 minus Q1, which is the value of 7. Then minimum value, that is, we can also call it as lower threshold. Q1 minus 1.5 into IQR, which is 6.5. And the maximum value is Q3 plus, that is upper threshold. This is lower threshold. Q3 plus 1.5 into IQR, that is 24 plus 1.5 into 7, that is 34.5. So here the minimum value is 6.5. Minimum value is 6.5 and the maximum value is 34.5 as per these calculations. So by seeing this, we can easily identify that 5 and 64 are the outliers of the given data set. Falling below 6.5, the value which is below 6.5 is one outlier, and the value above 35.5 is one outlier. So these are the two outliers of the given data sets. So let us impose all these points and let us represent with the help of a box plot. So how we are going to write the box plot? So before drawing the box plot, we have to draw a line which represent the values in the given data set. So when you see this data set, it is, so we remove this 5 and 64. Let us represent like 0, 10, 20, 30, 40, or else 0, 5, 10 also we can represent. So here I have represented as 0, 10, 20, 30, 40, so until 60. So here the Q1 is 17. So if you see here somewhere it is 17. So simply draw a line over here. Then Q2, that is median is 19.5. That is a very less distance should be there. Somewhere here 19.5. You can draw a line over here. Then Q3, it is 24. Somewhere here. So this represents a box plot. And here, this Q1 minimum value is 6.5. It is somewhere here 6.5. And here it is 34.5. The maximum value is 34.5. Somewhere represents here. Just simply join these two. Join this value where somewhere 6.5. And just this represents the box plot. Okay. And here you represent Q1 as 17. Q3 as 24 and median. And see, very less distance between these two and a maximum spread is there between these three. So median is 9.5. And we know that this 6.5, how we got is Q1 minus 1.5 into IQR. And how we got the maximum value is 34.5, that is Q3 plus 1.5 into IQR. And earlier, as per the calculation, outlier is 5 and 64. This is how we are going to represent all these 5 components in a single plot that is called as a box or whisker plot. And the numbers falling between these two, here and here, we can call them as whiskers. So that's why even this box plot, we also call it as the whisker plot. I hope you understood how to draw a box plot. So box plot also tells us about the distribution and symmetry of the data. The example shows the data is right skewed. Interquartile range shows that the middle 50% of the data lies between 74 runs to 24 runs. And whiskers of the box plot cover approximately 99.65% of the data. This is the conclusion of this particular. What are the statistics after seeing this box plot is? These are some of the conclusions we can draw from the given box plot. And one example for you students. So here is the question. The following data set shows the heights in inches for the boys in a class of 40 students. And these are the inches. These are 66, 66, 67. These are the heights in inches for the boys. And similarly, The following data set shows the heights in inches for the girls in a class of 40 students, and these are the heights in inches for the girls. So the question here is, construct a box plot using a graphical calculator. No need of the graphical calculator. You can simply, how I explained the previous example, try to find out Q1, Q2, Q3, or else 25th, 50, 75 percentile, IQR, then the outliers of this given data set, and then draw the two box plots. For one is for boys heights in inches and one is for the girls heights in inches, one other box plot, and come to conclusion that which box plot has a wider spread for the middle 50% of the data. Middle 50% of the data. So if you draw a two box plot for this, one maybe you got like this, other maybe you got like this, then which is having the question is which box plot has the wider spread for the middle 50% of the data. So by seeing these box plot, we can say that this second one is having the wider spread for the middle 50% of the data. Why? Because it is having less, here it is having more. So obviously this will has the wider spread for the middle 50% of the data. So, so students, try to find out the solution for this particular problem with the help of a block plot and try to calculate the 5 components as per the earlier example. Thank you.